Hi, I'm Tom with a list of interesting things. We're going to take a break from our rampant and fervent elections coverage to discuss something that people have been raving about since the beginning of the summer. From Stephen Colbert to the depths of Fox News, everyone has been worried about an asteroid that's set to make a near-Earth flyby on the 2nd of November, the day before the 2020 presidential election. So today on the inaugural installment of the list of interesting scientific things is asteroid impacts. We're going to discuss the relative chance of an impact, the relative danger thereof, and determine whether we're all going to die before we get a chance to count the votes. Let's dive right in, or perhaps I should say, let's hit it. Before we start, please bear in mind that I am once again recording in a storm with a different mic than usual, so if I sound a bit like a sultry NPR announcer in the middle of a hurricane, that's why. To start, let's establish what this asteroid actually is. It's officially called 2018 VP1. It's an asteroid that was first discovered in 2018 as it passed close-ish to Earth. From the path of its approach, astronomers were able to extrapolate its approximate orbit to show that it would be passing relatively close to Earth again tomorrow, on November 2nd, 2020. It's approximately 2 meters in diameter and is traveling at about 10 kilometers a second. Now, that may sound like a lot, but let's establish if it actually is. I'd like to illustrate the difference in size and threat of asteroids by using something called the Torino scale. It's a very rough and very broad scale for how big of a danger a given impact is. This is not to be taken as gospel, it's just a tool for conceptualization, but I think it's a useful one. On the y-axis, we have the relative size of the asteroids ranging from 0 meters up to 20 kilometers. And on the x-axis, we have the relative probability of an asteroid impact ranging from extremely unlikely to near certain. If anyone is unfamiliar with exponential notation, a negative exponent in this case can be described as 1 divided by the number featured. So 10 to the fourth power means 10 multiplied by itself 4 times, or 10,000. So 10 to the negative fourth power is 1 divided by 10,000, or a 1 in 10,000 chance. And herein lies my point. I think these things are fairly intuitive. The greater the size and the more certain the chance of impact, the higher the danger factor as measured by the Torino scale. So if you have an asteroid with a 1 in 1,000 chance of hitting Earth, that's 10 to the negative third power, and it's about 20 meters wide, I don't think that anyone should start panicking. That's about the size of a 2-story house, about the size of the Tunguska impact object. Now, an impact that large would be a problem. It would cause fires and shock waves like a volcanic eruption, as the asteroid burned up in the atmosphere. But after a few months of satellite and electrical grid repair, life would go back to something like normal, and anyway, it's pretty unlikely at those odds. However, if NASA or the European Space Agency or the Chinese National Space Agency spotted an asteroid with a 50% chance of hitting Earth at closer to 10 kilometers in size, or a little larger than Mount Everest, then we could all be forgiven for starting to freak out. Remember that the asteroid that caused the Cretaceous Tertiary extinction event 66 million years ago, the one that killed the dinosaurs, was somewhere between 10 and 15 kilometers across. An impact that large would be bad, bad news for just about everything alive on this planet. So let's return to the impact on November the 2nd, I should say, the potential impact on November the 2nd. Like I mentioned, this one is about 2 meters in diameter, about the size of a refrigerator, and it has about a 1 in 240 chance of impacting Earth. That's about the odds of rolling a die and getting a 6 3 times in a row. The chances are low, but certainly not impossible. So what could we expect, I should say, if an object that size hits Earth? Well, it depends on exactly what the asteroid is made of, but the quick answer is probably not much. If you happened to be looking up at the time, you'd see quite an impressive shooting star. It would likely light up the entire sky. If you were close enough, the impact might be followed by a tremendous bang, like a huge firework, maybe a few broken windows and some active car alarms. Impressive and maybe a little scary if it catches you unawares, but by no means civilization ending. The story here isn't that a world-ending asteroid is hurtling toward Earth. That's not the interesting part. The interesting bit about the story is that we caught it at all. This is kind of a proof of concept. A catalog has been growing among astronomers for years of all the sizable and potentially dangerous asteroids in the solar system. The fact that we were able to know where one is, even a little one, months before it gets to us, is an amazing thing. Which leads me to my last and definitely my favorite part of the story. Because we know where many asteroids are, and because we're learning the size and trajectory of more and more every day, we can defend against them. If a truly big asteroid like the Tunguska object or something even larger happens to come our way, then there are plans for how to deflect them, things like NASA's DART mission. This concept, simply put, is a battering ram. If we detect an asteroid headed for Earth some months in advance, specifically in this case a double asteroid, then we send up a probe and smack into one of the objects. This changes their orbital periods ever so slightly, which in turn changes their trajectory ever so slightly. Not much, but enough to knock it off its collision course with Earth. And are you ready for my science nerd self to come out? That is exactly what will be demonstrated in 2022. When the first test of this program is scheduled to be tried on the asteroid Didymus, pictured right here. Not that Didymus is headed toward Earth, this is just a proof of concept, but it's a super cool proof of concept. Now, there are dozens of other asteroid defense systems, but this one has me excited because it's so close on the horizon. It thrills me and inspires me. It speaks of ingenuity, even in the face of something that is both this awe-striking and this scary. I hope that you'll subscribe to stay up to date on all the most interesting things. There will be plenty more science videos just like this one after the election and all the ensuing chaos has calmed down. Until next time, be like asteroid impacts. Be rare and beautiful. And be explosive. And most of all, be interesting. See you next time.